Hello. This video is going to look at three very important concepts in evolutionary theory for chapter 15 in the psychology of learning. So this is going to look at adaptation, exaptation, and spandrel. Yes, that's right, spandrels too. Anyway, an adaptation is any sort of physiological process or behavior pattern that has historically contributed to the survival, right, of an organism over a long period of time, over an evolutionary time period. Now, the very important factor is that this is heritable. It's passed on genetically. Okay? So it has to be heritable. Something an organism learns in its own lifetime to do is not a biological thing that can be passed on to its offspring. That was an old, mistaken belief in evolutionary theory of the past, and that was the inheritance of acquired characteristics is what that was called, but we know today that that is not true. Okay? So an adaptation has to be heritable. Has to contribute to the survival of a species over time. Has to be something that has helped a species fit their environment and so survive, right? So an example of an adaptation the textbook uses is color vision, right? Color vision. So if you've had sensation perception and you look at basically the receptors at the back of the eye and the retina, we have rod receptors and cone receptors that enable us to interpret visual information coming in from the outside world, right? Now, rod receptors are much more plentiful, and so it seems that we had that first, these rod receptors, and those are basically good for helping us see during nighttime. So those are important in nocturnal creatures. And, well, mammals started off as nocturnal animals, right? And you still have some of those around today, like rats, right? Scurrying around in the night. Well, they need to be able to have better vision in the night because they're mostly nocturnal creatures. But after the big bad dinosaurs died off, because they no longer fit the new environment after the asteroid came, well, what do you know? These mammals that lived underground and scurried around at night to protect themselves from the dinosaurs, all of a sudden they fit this environment better. They started coming out in the daytime. And then, well, those mammals that could actually see better during the daylight were selected for, right? That characteristic was selected for. And so color and vision, these cone receptors, became more numerous over an extended period of time, trying to get rid of this flying bug, which unfortunately fits its environment and continues to irritate me. But anyway, so color vision became an adaptation. It was a physiological change in the organism, enabled the organism to survive and reproduce, right? Better in a particular environment, i.e. daylight. So that's an example of an adaptation. Now, you can also have an adaptation that evolves for an original purpose, which helps the organism survive and reproduce. But then, that adaptation also, by chance, happens to serve another useful purpose that helps the organism survive and reproduce over time. That would be an exaptation. The adaptation itself is co-opted for another purpose that also helps the organism survive and reproduce over a period of time, a species survive and reproduce, right? So the book mentions an example of an exaptation as feathers feathers originally evolving to help regulate the body temperature of early dinosaurs. Because you have dinosaurs, very clearly dinosaurs, that very clearly have feathers in them in the fossil record. It's also very clearly evident these creatures could not fly, all right, from their fossils. So they had feathers before, so feathers evolved before flight. So what must have feathers initially evolved for? that's the question. Well, regulate body temperature is the thinking. And then what do you know? Later on, after organisms had feathers and developed more and more feathers, oh my God, all of a sudden, this increase in, this better regulation of body temperature, all of a sudden these feathers also help the organism evolve the ability to fly, which also seems to be, really useful, right, for survival, for a species to survive and reproduce over time. So that is an example of an exaptation. Feathers originally for body regulation, temperature, and then they were exapted for flight, right? And then lastly, here we got spandrel. Last but not least, the spandrel, right? So an adaptation evolves. And whenever you make a change, for instance, in the physiology of an organism, make a physiological change in an organism, add a kidney, start making the brain larger, right? There are going to be side effects of that adaptation, right? So, if you add a second heart to an organism, well, there are going to be side effects of that, right? So the second heart might help circulate blood better, faster, whatever, but, it's going to have consequences, side effects. And of course, with the drugs we take, all of them have side effects, right? We take the drug for one particular purpose to help treat cancer, but it has side effects. It does all these other things. Same thing with an adaptation. You make a change in the physiology of an organism, there are going to be side effects. And if one of those side effects turns out to be useful and historically helps the species survive and reproduce over time, then that's a spandrel. That is a spandrel, right? And the example your book uses there for a spandrel, at least a possible example, because obviously we don't have time machines yet. But anyway, is the larger size in the brain, all right? So you can look at various species of, I don't know what to call them, of apes, I guess, right? Various species of pre-human organisms on this planet, and you can see their cranial sizes were getting larger and larger. They're not Homo sapiens yet, but their brains are getting larger. Why are their brains getting larger, right? Why is that being selected for? Well, they think, really, because there's not any evidence, these organisms did a lot, in terms of tools and that sort of stuff. So it seems like they were, more so larger brain size was being selected to help regulate body temperature. And what do you know, once you make a brain larger and larger and even larger, there's going to be a side effect of having a larger brain. That side effect is going to be sentience or conscious awareness or intelligence. Call it what you want. And what do you know? That's useful for survival too. How about that? There's a spandrel for you. Okay. So that is an adaptation, an exaptation, and a spandrel. I hope you have all three.